In the name of Allah, the most gracious, the most merciful. All praise is due to Allah, the Lord of all worlds. We seek His guidance and blessings as we gather here today. Dear faculty members, esteemed guests, and distinguished participants, we welcome you all to the 6th International Conference on Applied Zoology 2023 on the behalf of the Organizing Committee of ICAZ-2023 and the Applied Zoological Society of Pakistan. The organizing committee has managed to organize an appealing scientific event with multiple sessions for you according to your field of interest. I would like to extend my heartiest welcome to our keynote speakers from Turkey, Malaysia, and Italy. This conference will include 4 live oral presentation sessions from multiple fields of applied zoological sciences, including toxicology, entomology, nutrition, biotechnology, biochemistry, ecology, fisheries, physiology, microbiology, cancer biology, drug discovery, genetics, and histology. I believe you all will feel enriched with knowledge and scientific updates after completion of this international scientific event. I hope you all will have a very productive time ahead.
Creator, the ruby of universe, paralleled, and the teacher of teachers who changed the whole world and made us a better creature. To give tribute to our holy prophet, Hazrat Muhammad sallallahu alaihi wasallam, I would like to invite Miss Saira from BS 7th Evening, Government College University, Faisalabad, for Naate Rasool Maqbool. Please, Miss Saira.
गजल की खुशबू।
Thank you so much, Miss Saira, for such a humble and glorious tribute to our last prophet, peace be upon him. Now, it's an honor to invite Professor Dr. Farhad Jabeen, the Vice Chairperson of Applied Zoological Society of Pakistan and Dean Faculty of Life Sciences, Government College University, Faisalabad. She holds a PhD degree from ICAZ-2023 University, Islamabad. I request respected Professor Dr. Farhad Jabeen to join us and share her valuable insights with us. Please, Professor Dr. Farhad Jabeen.
In the name of Allah, the most beneficent and the most merciful. May peace, mercy and blessings of Allah be upon you. Honorable Chief Guest, Professor Dr. Ziaquljun, Executive Director, Higher Education Commission of Pakistan, worthy Vice Chancellor, Professor Dr. Nasir Amin, Honorable Professor Dr. Muhammad Ali, Chairman of the Applied Zoological Society of Pakistan, Vice Chancellor, BZU Multan and VC, Ghazi University, DG Khan, Dr. Abdul Shakur Chaudhary from Newcastle University, UK, Professor Dr. Yusuf Tudor from Turkey, Professor Dr. Abdul Jabbar from Melbourne University, Australia, dignitaries, Professor Dr. Salma Sultana, Principal Organizer of this conference, deans, chairpersons, directors, professors, researchers, faculty and students, Assalamu alaikum. On behalf of the Applied Zoological Society of Pakistan and Government College University, Faisalabad, I would like to express my sincere gratitude and welcome you to the 6th International Conference on Applied Zoology, ICAZ-2023. The ICAZ-2023 is an annual international conference carried out regularly by the Applied Zoological Society of Pakistan. Since this year, the theme of the conference is tackling the global challenges through the applied zoological sciences. The 6th ICAZ-20 offers a special opportunity to bring together professors and scholars around the globe and serve as a platform to deliver innovative research finding strands and development in the applied zoological sciences. It is my hope that the 6th International Conference on Zoology would be able to achieve its objectives in providing an effective forum for academicians, researchers and practitioners to advancing knowledge, research and technology for humanity. It is pleasing to know that the agenda of this conference covers a wide range of interesting topics related to all theoretical and practical aspects but not limited to this. Last but not least, my deepest gratitude goes to the organizing committee, institutions, companies and volunteers have directly and indirectly supported the success of this conference. I wish you a very productive conference with exciting and encouraging discussion and exchange of knowledge so that together we can anticipate a flow of groundbreaking knowledge, research and technology for humanities. May God bless all with good health to make this event a successful and enjoyable one. Enjoy the conference. Thank you all.
Thank you, Professor Dr. Farhad Jabeen, Vice Zoological Society of Pakistan and Dean Faculty of Sciences at Government Faisalabad. Now, I would take it as a privilege to invite focal person of Applied Zoological Society and an organizing secretary of 6th International on Applied 23. He is an assistant professor at Government College University, Faisalabad. Please.
Sir. Bismillahirrahmanirrahim. I would like to welcome you all at ICAZ 2023. This is the 6th International Conference organized by the Government College University, Faisalabad in collaboration with the Applied Zoological Society of Pakistan. So, Alhamdulillah, this is our 6th conference. As first we have organized in GCU Faisalabad, then we have moved to the ICAZ University, and last year we have organized in Kafute, Khaja Farid University, University of Science, Rahim Khan. So this time again we back to the GCUF, and this year we are going to take it as a mega event. In this we have a participation more than 90 national universities and 20 international universities, with the participation about 1500 plus. And then we also have, of course, the online participation, the part of the online participation more than 400 plus. So inshallah it is one of the mega event in the whole country. There's no station. So hopefully have the talks in different disciplines. We have from of applied sciences such as microbiology, from chemical sciences, cancer biology, wildlife, fisheries, entomology, and many more. We are going to listen the speakers from the different countries such as from Kazakhstan, Turkey, UK, and Chile, and we have some other countries also, and also number of the national universities. So the physical, which will the present you will be see in the GCUF, and some will be online lecture speakers and also our national speakers. So hopefully this is one of the mega forum in which you have a lot of networking, interaction with the different researchers, and hopefully these two days will be the way, and you will have a lot of interesting talks and interesting new avenues for the innovations. So I hope this conference could be the new lead and for the generations and our students, the young faculty members. So hopefully, and that forums will be the great forum. So I again, of course, welcome you all in this inviting in the inaugural session of the ICAZ-2023. You will enjoy our physical as well as our online sessions. So I think this is kind of the events which you are looking for, and we all are waiting for these events from the last few months. Hopefully it is now is in online. So please enjoy these 2 days, and we will wait for your comments. If you will feel any difficulty, encourage you can write it in the comments, and we will improve next inshallah conference that is going to be held, of course, inshallah, in 2024. So have a good time and enjoy your learning with our national and international speakers. Thank you all and stay blessed.
Thank you so much, Dr. Azhar Rasool, to share your insightful thoughts. It's always a pleasure to have you. Now this session is going to end. Our session would be plenary session that would be moderated by Miss Rabia Zara. Now it's hand over to you, Miss Rabia Zara. Thank you so much.
Ma'am Shabir. Now it's time for our plenary session. Our speaker is Professor Dr. Volkan Yupoglu, Faculty of Science, Department of Chemistry, Kankaya Karatecan University, Turkey. And he will talk about recent advances in membrane science and technology in the aspect of 3D printing. Please, Professor Dr. Volkan.
Hello and assalamu alaikum, dear participants and organizing committee and chair of 6th International Conference on Applied Zeology. My name is Volkan Yupoglu, Professor Dr. Chemistry Department of Çankırı Karatecan University from Turkey. I would like to mention in today's presentation recent advances in membrane science and technology in the aspect of 3D printing. Know that processes take place in lots of scientific applications, and it forms the heart of the science and the technology actually in today's industrialized world. So we need to prepare different shape and different sizes and different designs of the membranes, and combining different materials to form composite membranes and other shapes and the style of the membrane for different purposes. For that reason, we are trying to find new techniques and technologies for membrane preparation purposes. It's new one, 3D printing technologies. Firstly, we need to 3D printing technology that inshallah we will try to get the information and some applications of the 3D printing based membrane preparation and its application at the end of the presentation. Firstly, let's start to recognize 3D printing techniques and its basic applications and the fundamentals. 3D printings and rapid prototyping has the ability to create almost any geometrical complex shape or feature in the range of the materials across different scales. On the other hand, its use in separation membrane engineering is relatively new. Because of the techniques is new and technology is new and developed every day, and we can find the different possibilities and the different techniques. This technique and this technique family also facilitates membrane separation systems and offers separation abilities that are able to produce membrane of different shapes, types, and designs, which cannot be made using conventional such as the or sintering. You can see the basic 3D printing machines and the devices at the right side of the slides also. If we compare the 3D printing application and membrane applications together, computer-aided design also most important part of the 3D printing, converting the CAD and L or objective or AMF extension files. A model is sliced into layer by layer. After that, 3D printer fabricates the parts, layer by layer fabrication. And after that, you can apply some post processing, doing the best the printed materials and etc. Sometimes we are using polishing techniques. Sometimes we are using graving techniques and the others to make it beautiful and good shape and exact and rigid. If we compare membrane possibilities, membrane features, and then their 3D printed material. For example, we can, if we produce by the 3D printing techniques, we can get high resolution, applicable materials, and speed, and overall reducing our in the production in the 3D printing techniques. What we can produce actually in the membrane separation techniques, we can produce spacers, direct membranes, solar absorbers, carrier media or capsules, and modules, ceramic filters, photocatalyzers, and the absorbents we can produce. And with the high resolution, applicable materials, overall cost reducing, and the speed scalability by the 3D printing techniques also available. When we recognize the 3D printing techniques also, firstly, we can see that in this slides also, photopolymerizations. In this techniques also liquid resins in this printing techniques. We are using a laser and UV laser depending on the resin requirement for the polymerizations. And then we can share layer by the photo polymerizations reactions. Layer by layer production is available in this techniques also. In this techniques, we can see 4 different current techniques also in the 3D printings for photopolymerizations. First one, SLA. It's also can be seen in the market, and then material techniques. It's ergo sensitive techniques. It's not available in the market, but you can produce it easily for the lab scale studies and the others also. And the other one, TPP and SLIP. Their production techniques is a little different, and depending if you follow the scheme related to the, also you can see how to produce and how to use and how to fundamentals the 3D in the slides. Another techniques producing the powder type materials. For that reason, we are using the thermopolymer resins and the support polymers together also. We are using the heated extruder, and we are mixing the support resin and the thermopolymer resins together by direct heated printed head or laser scanning systems. Also we can use it and we can produce it easily. For that reason, we can use some different thermopolymer resins and others in the, and then we can do it by the heated head or laser scanning system or on the powder bed. And another one, extrusion. It's most available and easily available 3D techniques in the market. Extrusion of the thermopolymer resins and support resins is required or unrequired depending on the polymer types and the polymer chemicals. And we are using heated material, and then this heat extruder melt the thermopolymer resins, and then extrusion starts for a layer by layer production. And then extrusion type 3D membranes also available in the market, FDM type and the DWA type things also available. Another one, lamination type 3D printing techniques. In this techniques, we can use paper type foils or flow type foils together. And first one of the lamination type 3D printing, we are using the foil supply, and then this foil flows on the 3D membrane surface. And then scanning laser system. Lasers also touch the foil parts together, and then we can produce what we want to make easily in the 3D printer also. Another one, paper type polymer materials also to the 3D printing, and then the hot plates also stick it together, and then we can produce it easily. And at the end of this 4 slides, we have recognized fundamentals of the 3D printing techniques and how to work the 3D printings in which purposes in the membrane preparation. And right now we are ready to understand how to apply the 3D printing techniques in the membrane preparation purposes. Actually, in that point, we have to mention current 3D printing resolution limits also. In membranes and spacers and modules, if we separate different membrane parts. As you know that membranes modules includes spacers and membranes together. We are combining the membranes and membrane spacers, and depending on our membrane modules requirement, and then we can produce the membrane modules. In the 3D membrane preparation techniques, we can reach the resolution limits in the module preparation 10 millimeters to 1 meters. We can produce the membrane. In the spacer production by the 3D printing techniques also, we can reach the 1 micrometer to 10 millimeter range of the spacer production. And similar to spacer productions in the membrane production, depending on the polymer resins, chemical structures and the chemical properties, we can get and also applied 3D printing techniques also, where we can get 0.1 nanometers and 1 micrometer range membranes we can produce by the 3D printing techniques also. In this techniques also, we can get 0.1 nanometer for size to 100 nanometer for size, and in the spacers also thickness size microns to the 10 millimeters, and we can get depending on our requirement. And module doesn't need to structure, so we can get the small size to the bigger size module caps in the 3D printing techniques in the membrane preparation purposes. Base membrane preparation, if we look at by the 3D printing, actually, we are using thermoplastic materials and heated extrusion head, and this extrusion starts with layer by layer deposition on the heated platform of the 3D printing, and then in the membrane preparation, actually, we just need to maximum 10 layer of the membrane production if we need to prepare the layer based or sheet based membrane production. But if we need to different shape and the different types of the membrane by using the different polymer resins for absorption purposes and membrane separation purposes to increase the surface area of the membrane, we can produce different shape and the different types of the membrane as well. And another techniques also, after make the production of the basic membrane, we can use the sintering techniques by the laser beam or heated plunge or other plasma techniques also can be used for the sintering purposes on the membrane surface. And filling powder, and after that we are scanning the system by the laser, and then we can get the sintering of the membrane materials on the surfaces on the powder bed. Okay, and another techniques also, stereolithographic production of the membrane. Stereolithographic membrane preparation also so high technique and high sensitive membrane preparation techniques. You can produce the lithographic materials like cubic shape and hexagonal shape and the pentagonal shape and the other shapes. All shapes is possible in this membrane preparation techniques also. We can prepare the membrane in the different shape by the lithographic methods, and then we can use it membrane under steady state conditions. The color change of the pH indicator from blue to yellow again indicates the carbon dioxide transport through the PDMS membrane easily. And look at the workflow and the workflow scheme below. You can see how to prepare the membranes. Rapid prototyping of membrane inside the Schwarzschild geometry in the figure also green one, and then we are using the case of the polymer material, membrane materials, put it into that, and then we can PDMS molding applications also membrane has been inside and then mold leaching and contacting with the carbon dioxide. If you look at the application of that, 3D printed PDMS membrane contactor, gas flow horizontally from left to right, while the bromothymol blue pH indicator is pumped vertically bottom to top through the contactor. The color change of the pH indicator from the blue to yellow indicates the carbon dioxide transport over the membrane. As we see in this applications example, that we can produce the different shape and different type and different lithographic materials for the membrane preparation and membrane separation purposes in different applications, from heavy metal separations, heavy metal removal, gas separation, perforation, electrodialysis purposes, and the other all membrane separation processes is available by the 3D printing technique. Thank you so much for your attention and participating and listening my presentation patiently. And thank you much again. في أمان الله مع السلامة.
Thank you, Professor Dr. Volkin, for your informative slides. Now, I'm delightful to invite Dr. Fatma Kais, Department of Earth and Environmental Sciences, University of Milano, Bicocca, Italy. And she will talk about the impact of eutrophication on zooplankton community structure and dynamics. Please, Dr. Fatima.
Hello everyone. Firstly, I would like to extend my sincere thanks to all the organizers of ICAZ-2023 for inviting me. I'm Dr. Fatima. I will present a communication today on the impact of eutrophication on the structure and dynamics of zooplankton community. Firstly, we need to know eutrophication. Eutrophication is the excessive growth of plants and algae due to the increased availability of nutrients such as nitrogen and phosphorus in aquatic systems. Can occur naturally over centuries or be accelerated by human activities such as agriculture, industry, and sewage disposal. Why is eutrophication problem? Eutrophication leads to decrease in hydration and oxygen levels, causing harm to aquatic life. Cyanobacteria dominance and the production of toxins contribute to the loss of biodiversity and the creation of dead zones. It can have negative effects on water quality, biodiversity, fisheries, and health. Some of the consequences include algal blooms, cyanobacterial toxin, hypoxia, pH fluctuations, and the changes in food web structure and function. Eutrophication can lead to an increase in the production of phytoplankton, which zooplankton feed on. However, excessive eutrophication can also lead to oxygen depletion and the formation of harmful algal blooms. Butterfish can negatively impact zooplankton populations. Eutrophication, the process of increased nutrient levels in an aquatic ecosystem, can have significant impacts on zooplankton community structure and dynamics. Zooplankton plays a crucial role in aquatic ecosystems, facilitating energy transfer from lower to higher trophic levels in the aquatic fish, being sensitive to environmental changes. The relationship between eutrophication and zooplankton community structure can be observed in various ways. Zooplankton biomass. Eutrophication is associated with an increase in the summer biomass of a total zooplankton calanoids and large cladocerans, but not cyclopods. Top-down effects such as predation can mediate zooplankton diversity in a work structure, resulting in structural adjustments of zooplankton communities. Relationship with phytoplankton. The relationship between zooplankton biomass and phytoplankton biomass can provide insight into a structure and the function of lake biological communities. Temperature sensitivity. Eutrophication can strengthen the response of zooplankton to temperature changes in a high-altitude lake. Size structure dynamics. Variability in zooplankton community size structure is related to eutrophication parameters, including total phosphorus, total nitrogen, chlorophyll, and the Secchi depth. Invasion species. Eutrophication and associated cyanobacterial blooms can also impact the plankton community dynamics by facilitating the invasion of non-native species. Zooplankton communities demonstrate fast responses when disturbances occur, including eutrophication, acidification, predation, and hydrological changes. These responses can be used to monitor environmental changes in aquatic ecosystems. How does eutrophication affect the diversity of the plankton species? What are the long-term effects of eutrophication on the plankton population? Can the plankton adapt to eutrophication, and if so, how? I have selected for you various interesting papers that have been done all over the world. The effects of eutrophication on the plankton are complex. It's important to understand the nuanced and multifaced effects of eutrophication on the plankton. Eutrophication is characterized by the rapid growth of plankton due to the elevated nutrient levels and increased atmospheric carbon dioxide. On the other hand, nutrient pollution from water runoff can trigger eutrophication process that pose environmental hazards. Listed below are the positive impact of eutrophication to the environment. First, improves biodiversity. Second, aids in waste removal. Third, boosts ecotourism. Fourth, source of medicine. And finally, better water quality for some species. What strategies can be used to mitigate the impact of eutrophication on zooplankton? How can eutrophication be managed? The most effective way to prevent and reduce eutrophication is to control the source of nutrient inputs into aquatic systems. However, this can be challenging and costly, especially for non-point sources and large-scale ecosystems. Other strategies include physical, chemical, and biological manipulation of water bodies, such as diversion, mixing, sadding, and biomanipulations. However, these methods have limitations and trade-offs and may not address the root causes of the problem. According to Solomon 2023, eutrophication is a significant ecological challenge that negatively impacts aquatic ecosystems and the availability of clean water. However, various techniques have been developed to mitigate eutrophication, including chemical coagulation, adsorption, and biological methods. The use of nanofiltration membranes coupled with a bioreactor has also been successful in removing various nutrients from wastewater. Finally, the most effective method of management is the long-term policy and periodic development actions. Thank you for your time and attention during this oral communication. I appreciate the opportunity to discuss and exchange ideas with you. If you have any further questions and need clarification, please feel free to let me know. Thank you again.
Thank you, Dr. Fatima, for your constructive intuitions. Now, I would like to invite our third keynote speaker, Dr. Liam Nitschin, Institute for Research in Molecular Medicine, University San Milicia, Kuala Penang, Malaysia. And he will talk about strategies for the oriented immobilization of antibodies through linker-mediated approaches for use in immunosensors and diagnostic applications. Please, Dr. Liam.
Thank you for the invitation for the 6th International Conference on Applied Zoology. Thank you again for the invitations. My name is Dr. Lai Shins, and I'm from a lecturer from University Institute for Research in Molecular Medicine, or called INFORM, from University Science Malaysia. Today I'm going to share topics that is strategies for the oriented immobilizations of antibodies through linker-mediated approaches for use in immunosensor and diagnostic applications. I hope you will enjoy the talks. So for the introduction parts, immunosensing. What is immunosensing? Immunosensing is an analytical method that uses antibody to detect specific antigen with high sensitivity and specificity. And antibody are the protein that bind to the antigen with their Fab regions, while the FC region is not involved in the antigen recognitions. Antibody immobilization is a key step for immunosensing as it affects the antigen binding capability and the signal to noise ratio of the detection system. So next we're gonna talk about the challenges of the conventional antibody immobilization methods. So random orientations of antibodies on the solid support or surface can be lead to denaturations, steroid hindrance, and loss of activity of the Fab regions. Also, surface sensitivity of the antibody on the solid support or surface need to be optimized to achieve the high sensitivity and low background. Lastly, and non-specific absorption of other proteins or molecule can cause the interference and noise, and it can cause a non-specific detections. This is the figure show the antibody structure and various orientation of the antibody on the sensing surface. The common ones is end on, and the other three is a flap on, hit on, and side on. These three is considered is not a favorable binding type of for detections. Next, we're gonna discuss about a linker-mediated immunoassay or MAI as a solutions. MAI as an immunoassay, they can use linker molecules to mediate the oriented immobilization of antibody on the sensing surface. Also, immobilized molecules are bioaffinity ligands that have specific or reversible binding to the FC region of antibodies such as FC binding proteins, FBPs, DNA, biotin and streptavidins, and FC binding peptides. So, LMN or linker-mediated immunoassay also have advantage such as control orientations of antibody. This is which means it can maximize the antigen binding capacity and improve the sensitivity and limitation of detection of immune sensor. Next, second is no modification of antibodies is required. This is good, which can preserve the native structure and function of the antigen binding site. Lastly, low background noise and high signal to noise ratio as a linker molecule can prevent non-specific absorption of other molecules. So this is a summary of the strength and limitation of each linker-mediated stepwise oriented immobilization method. It consists of FC binding proteins, DNA derivatives, biotin streptavidin, and FC binding peptides. So it shows all the mechanism, the strength, and the limitations. Next, we're gonna share about the FC binding protein, SBPs, mediated immobilizations. FBP are the proteins that are bind to the FC region of antimolecules such as protein A, protein G, and their Z domains. FBP can be absorbed or covalent bind attached to the sensing surface and the capture of antibody via the FC region, leaving the Fab region free for antigen bindings. FVP has several strengths such as high specificity and affinity for different type and subclass of antibody type of species, and no interference with binding activity of the antibodies. While they have FVP have the strengths, FVP also have limitations such as reversible binding between antibody and FVP, which can affect the storage stability and reprocessability of the immune sensor. Second, binding to FC region is also of some antibody, which can cause a non-specific binding and loss activity of the antigen binding site. Lastly, additional immobilization step of FVP is needed, which can be increase the complexity and the cost of the biosensor. So this is a summary of various FCM technology using a bioaffinity linker. We have a FC binding protein, DNA directed, structure binding, FC binding peptides, and others. So they can show the limit of detections, linear range, or what's other information. This table also show the improvement compared to random immobilization. What is better than compared to other method. Next, we're gonna discuss DNA-directed immobilizations. DNA directed immobilization, or DDI, is based on the formation of hydrogen bond between complementary oligonucleotides, a single-stranded DNA that can be conjugated to the antibody and their sensing surface. So the DDI also can perform non-covalent coupling oligonucleotide to the antibody via different type of method. First, usually is the biotin-structure-binding interactions, disulfide and maleimide couplings, benzoyl acid pentafluoropenic ester (PA), PFP, and lastly, which is the famous one, is the click chemistries. DNA-directed immobilization also have show several strengths and for immobilization, such as it show a high specificity and stability of DNA interaction, which can ensure the orientation, immobilization, and the regeneration of the antibody. Also, DDI also show a high surface coating density and flexibility of the DNA strand, which can be enhance the antigen capture efficacy and improve the assay sensitivity, which is very good. While the last one is the advantage is possibility of multiplexing, which means that different antibody can be immobilized by using different type of DNA sequence. Although the DDI have this is strength, but DDI also shows some weakness in some part. One is a modification of both antibody and surface is required, which can increase the production cost and operation time of the immunosensor. Also, last is the site and DNA conjugation will determine the final orientation of the antibody, such as the antibody have multiple reactive group that can cause a random conjugation and formation of inactive conjugates. Next, we're gonna discuss the topics biotin structure-binding mediated immobilizations. Biotin structure-binding mediated immobilization is based on the non-covalence, interaction between biotilated antibody and structure-binding coated surface. So biotin structure-binding also this mediated immobilization can be performed by different method. Is biotilated antibody via different methods such as biotin NHS chemistry, Hinger's disulfide biotilations, and sugar chain biotilations. Structure-binding mediated immobilization have several advantages. So one is the high stability and irreversible of the biotin structure-binding binding. We can be ensure the robustness and the reproducibility of the immunosensor. And also is biotin structure-binding show no effect by physical restraints such as pH and temperature. These two factors can be increase the versatility and applicability of the biosensor. Although biotin structure-binding mediated immobilization have an advantage, this also shows several disadvantages, such as first, additional steps for the biotin conjugation and structure-binding immobilization are needed, which can be increase the cost and the complexity of the immunosensor. Site and biotin conjugation will determine the biotin's configuration, as biotin and acid chemistry can cause a random biotilations and loss of activity of the antigen binding site. Next is we're going to discuss the FC binding peptide mediated immobilizations. FC mediated peptides are short peptide, synthetic peptide that can bind to FC region of antibody, such as EYK peptides, Z33 peptides, and FCBP peptide. FC binding peptide can be absorbed or covalent attached to the sensing surface and then capture the antibody via their FC region, leaving the FC region free for antigen binding. FC binding peptides has several advantages, such as high specificity and affinity for different type of subclass of antibody for rare species. No modification of antibody is required, such as preserve the native structure and binding of antigen binding site. And last is no interference with the binding affinity of the antibodies. Fc binding peptide has, however, a disadvantage drawbacks such as additional step for peptide conjugation is needed, which can increase the complexity and the cost of the biosensor. The last one is the Fc binding peptide also affected by the physical restraints such as pH and temperature. You can expect the stability and reversible of the peptide antibody bindings. Lastly, we are going to discuss the other linker-mediated immobilization strategy. Besides that, there are some other methods which are reported is antibody binding aptamer, which are short single-stranded RNA or DNA molecule that can bind direct to Fc region or antibody with the high specificity and affinity. So these aptamers is considered among the most hotspot of research for the antibody binding aptamers. Next is antibody binding polymer, which is also a synthetic polymer that can bind to Fc region of antibody with high selectivity and stability. So the linker-mediated immobilization strategy can compare based on several criteria such as orientation control. It means the degree of control over the antibody orientation of the surface can be determined which is the best of type of immobilization. And antibody modification also needed for either is chemistry or biological modification of the antibodies. Surface, the need for chemistry or biological modification of the surface is also one of the factor that can be considered. And binding strength and binding specificity also is gonna affect the strength and reversibility of the linker antibody bindings. And binding interference. Binding interference, the interference or the influence of the linker on the antibody bindings, which determines the type of immobilization strategy should be chosen. And lastly, I think for the most important, usually for scale up, cost and complexity. The cost and complexity of the immobilization is also one of the factors should be considered, because with the higher cost, definitely it will make the product more interesting for the buyer. Thank you for your attention. I think for your detail of readings, I think you should refer to the journal published in the Biosensor and Bioelectronics this year. And thank you very much for your attention. Thank you.
Thank you, Dr. Lai, for your informative talk. Now, the plenary session has come to an end. I am thankful to our all keynote speakers deliberating in various areas of biological sciences. All the constructive intuitions give us a new perspective of advancement in biological sciences. Now, we will have our first oral presentation session at 10:30, which will include talks from the fields of toxicology, entomology, and nutrition. Thank you for your participation. Stay tuned with us.